Hi class, welcome to this new video on quadratic forms. We're still on the fourth chapter of this course titled Diagonalization. Remember that in the previous video, we saw how to diagonalize a matrix, how to find the eigenvalue, the eigenvector, and how to orthogonally diagonalize a matrix. All these notions will be extremely useful in this section of quadratic forms. Now, why is it important to study quadratic form? Because quadratic form will help us to understand a quadratic equation as the graph of a conic section in the plane. Now, let's have a look on what is a quadratic form in definition. Let's consider that A is a symmetric matrix, n times n symmetric matrix with a Hill entry, and X denotes an n times 1 column vector. Then Q equal to xt ax is said to be a quadratic form. Xt here is the transpose of the vector x. So let's say now that x is written as this, and a as this, and x as this. If then we want q, which is x transpose xt ax, we have that is equal to this. So if I multiply these two first, I will have this, and then having this, I can then multiply with this vector, then it will give me this a11x1 plus a12x1x2 plus a1nx1xn plus a21x2x1 plus a22x2 square plus a2nx2xn, which is which will be equal to, right, the sum of I less or equal to j of aij xi xj. So this, right, from this one that we call the quadratic form in terms of matrix, we got an expression in terms of the quadratic of the element of the matrix of A and the vector x. Now, let's have a look on this beautiful example. Consider having matrix A, which is 2, 1, 2. It is 1, 2, 2, 1, and you have x equals to x1, x2. The question is, what will be the quadratic form, right? So to have q, we know the formula, right, of the quadratic. So it will be equal to x1, x2 times 1, 2, 2, 1 times x1, x2, right? So this will be equal to, if I multiply these two first, right? So I will have that x1 plus 2x2, 2x1 plus x2, x1, x2, right? Which will give me that x1 square plus 4x1, x2 plus x2 square. Okay, so we can see that from an expression of x transpose ax, this is a matrix form, we can have its equivalent in terms of quadratic equation, which is well known. So on a general basis, a quadratic form in two variables is written as ax squared plus 2bxy plus cy squared plus dx plus ey plus f equals to 0. And we call this 1. This equation 1 can be written in terms of matrix form as x, y, a, b, b, c, x, y plus d, e, x, y equals to minus f. So we call this 2, right? So this is a quadratic form, and this is the matrix form of the same quadratic, where at least the coefficient A, B, and C, at least one of these coefficients, at least one of A, B, C are not 0. Now, remember at the very beginning of this video, I told you that the main problem of the quadratic form is how do we understand a quadratic equation as a graph of a conic section in the plane. So this is the main idea behind this video. And remember that there are three types of conic section, right? So the first one are the ellipses and the cycles with conic equation x squared over k squared plus y squared over l squared equals to 1, this is L. And then 2, we have the hyperbolas, which is x squared minus k squared minus y squared over L squared equals to 1. And then we have, thirdly, the parabolas, where you have y equals to kx squared or x equals to ky squared. So these are the three conic sections that we have. Now, it is important to know that from equation 2, right, from equation 1 or 2, right, it is important to realize that if this term, if the xy term is 0, right, then we can easily obtain a conic section in the plane by reducing the equation to one standard form by completing the square. Now, I hope you understand what we're trying to say. Now, let me say it one more time. If this term is 0, then it becomes very easy to obtain the conic section in the plane by reducing the equation, right, to one standard form by completing the square. For example, if we have the quadratic equation x squared plus 9y squared plus 64x minus 18y minus 71 equals to 0. The question is to plot or determine this surface. Now, having this, we have to complete the square. So we have 16xy plus 16x squared plus 64x, right, plus 9y squared minus 18y equals to 71. So from here, if I put 16 in factor, I have x squared plus 4x plus 9y squared minus 2y equals to 71. So, and this will lead to, you see, if I complete the square here, I will have x squared, right, plus 2. I'll have x plus 2 squared minus 64. I just completed the square for this. And then plus 9 factor of y minus 1 square minus 9 equals to 71. Now, this will be also equal to x, 16x plus 2 squared, right? Yes, plus 9y minus 1 squared, right, equals to 71, right? 71 plus 64 plus 9. So this will lead, and if we do the division, x plus 2 squared over 3 squared plus y minus 1 squared over 4 squared equals to 1. Now, what is this figure, this plot, this surface, according to what we describe here? So we can see that this equation will be an ellipse, right? This will be an ellipse where the center is of coordinate minus 2, 1, and the smaller radius will be 3, and the bigger will be 4. So this will be the surface described by this quadratic equation. In the next video, we will solve some more practical cases on quadratic form. Thank you.